Hello and welcome everyone. You're welcome to the ICCP Conference 2021, which is being conducted online. To start off the conference, we would like to ask Medha Deshpande, who's a doctor at the Indian Institute of Tropical Meteorology, to take us through a spiritual journey. Medha, please.
Yeah, thank you, Anu. Raj Gajanan Payore Gadaraj Gajanan Payore हस्त में परशु पशांकुशधारी हस्त में परशु पशांकुशधारी हस्ति के मस्तक दैत्य विदारी राज गजानन पायो रे गणराज गजानन पायो रे शिर पर किरीट बिराजित भारी कान में कुंडल झलके मयूरी तिलक करे कर्पूर केसरी अंग विभूषित लाल सेंदुरी राज गजानन पायो रे गणराज गजानन पायो रे पहरे पीतांबर उस पर फणिवर पहरे पीतांबर उस पर फणिवर बांध लिए शिव शंकर प्यारे मुक्तिदास प्रभु भक्त कैवारी गौरी नंदन दीनोधारी राज गजानन पायो रे गणराज गजानन पायो रे.
Thank you, Medha, for starting us off on a very melodic and a beautiful note. Next, I would like to ask Dr. Thara Prabhakaran to give an introduction to all the dignitaries and also to tell us a little bit about the ICCP conference.
Very good morning, good evening, and good afternoon, and welcome everyone. I first welcome our Honourable Secretary, DST, MOST, and MOS, Professor Ashutosh Sharma, and DG, IMD, Dr. M. Mohapatra, Director, IITM, Professor Ravi S. Nanjundiah, and National Organizing Committee Chair, Professor G.S. Bhat, and President ICCP Commission, Professor Andrea Flossmann, Vice President ICCP Commission, Professor Greg McWaffer, Secretary and Treasurer, ICCP Commission, Dr. Daryl Baumgartner, and Program Advisors at the Ministry, Dr. Gopal Iyengar and Dr. Parvinder Maini. And International Conference on Clouds and Precipitation, ICCP 2021, is the Olympics of cloud physics, conducted every 4 years, just like the Olympics, by the ICCP Commission, an international body of scientists and students. It is happening for the first time in Asia. And ICCP conferences are attended by several experts in the field and scientists, students, and they report latest advances in the field of cloud and precipitation sciences. And ICCP 2021 is a testament that as a community, we can stay above the hardships around this time and make progress in science. It has been a difficult time for all of us, and we would have loved to welcome you all in India, in Pune, for a conference in person. I'm sure that although not in here physically, you will be with us in the spirits. Cloud physics is a subject of importance to the society in various ways. What happens at a cloud droplet level or within a cloud has considerable implications on weather and climate forecast. We need better observations and detailed understanding of the basic processes to improve our models. Indeed, cloud processes are one of the biggest uncertainties in the models. ICCP looks at most of the aspects of cloud and precipitation processes, and even at applied fields such as weather modification and severe weather. IITM has placed a bid for the ICCP conference in 2016 at the 17th ICCP conference in Manchester, and was awarded the chance to host this 18th ICCP in Pune. IITM has taken efforts to conduct the ICCP and its messages, deliver its messages to the masses. So we have used the best available virtual platforms to make it more interactive and informative. Special attention is given also so that you don't lose the magic of in-person conference. So wish you all a fruitful and successful conference. I hope to see you in person in the near future. Thank you.
Thank you, Dr. Thara. Next, I would like to invite the Director of IITM, Professor Ravi Nanjundiah, to give a welcome address.
Thanks, Anu. Professor Ashutosh Sharma, Secretary DOST and MOES, Dr. Mohapatra, DG IMD, Professor Bhat, Professor Andrea, Flossmann, Dr. Thara, and all the dignitaries on and off the dais. Ladies and gentlemen, it gives me great pleasure to welcome all of you to this international conference on clouds and precipitation, being held, unfortunately, in a virtual mode and being hosted by the Indian Institute of Tropical Meteorology. We would have loved to have hosted you in physical mode, but for the pandemic. The response to the conference has been overwhelming, with a large number of participants, especially students from many countries. In this conference, all aspects of clouds, convection, and precipitation will be discussed in great detail. These discussions would provide new and deeper insights about clouds, convection, and issues such as cloud aerosol interaction. This in turn could pave the way for improved representation of clouds in models. As just now Dr. Thara said, this is one of the weakest links in our models. And this in turn would help us to improve our forecasts. And the take-home message from this conference would be invaluable. As you are all aware, forecast of monsoon is a major problem for most models. In the context of India, improvements in forecasts will be a boon for all of us Indians. I welcome you again to this conference and look forward to exciting interactions in the coming days. Thank you. Jai Hind.
Thank you, Professor Nanjundiah. Next, I would like to invite our chief guest of the day, Honourable Secretary of DOST and MOES, Professor Sharma, to say a few words.
Namaskar. I am so delighted to join with all the scientists and participants in the 18th conference of the International Commission on Clouds and Precipitation. And I'm happy to see with us DG Dr. Mohapatra, Director Professor Ravi Nanjundiah, National Organizing Committee Chair Professor Bhat, and my congratulations to all the organizers, as well as the organizers from ICCP Commission who are with us, Professor Andrea Flossmann, Professor Greg McFarker, Dr. Daryl Baumgardner, and the officials from Ministry of Earth Sciences, Dr. Gopal Iyengar, Dr. Parvinder Mani. So it surely looks like you are doing a great job of organizing the conference, and my congratulations to all for bringing together such a large number of scientists who work in this very important area. Every time the monsoon comes in here, everybody is so happy, and we certainly need to understand the science behind it all. The ICCP conferences are organized every 4 years by the International Commission on Clouds and Precipitation, together with a host institution. ICCP, as we know, is a commission of the International Association of Meteorology and Atmospheric Sciences and Association of IUGG, which is International Union of Geodesy and Geophysics. The Indian Institute of Tropical Meteorology, IITM, is hosting this international conference for the first time in India. This is indeed a great event for all of us, for the whole Indian community of scientists who work in this area. It would certainly be very inspiring for them. And I'm really delighted to learn that more than 500 scientists working in cloud and precipitation worldwide will be participating in the conference. Now we know that monsoon is a rather complex phenomenon, and so it's difficult to forecast. Especially the Indian monsoon has got some angularities, if you would. Having worked with Navier-Stokes equations for about 2 decades, myself, I can certainly understand the complexities that loom rather large in predicting very accurately the monsoon details for India. And while a whole lot of countries around the world are making tremendous efforts to improve their skill of predicting monsoonal rainfall, especially in India. Now, the monsoon mission was launched in India in 2012 as a mission by Ministry of Earth Sciences with a vision to develop a state-of-the-art dynamical prediction system for monsoon rainfall. Ministry of Earth Sciences made significant progress in prediction of seasonal forecast of monsoonal rainfall. The remarkable improvement in the skill of the forecast, especially in short to medium range, has also been achieved. Predictions, while at this point I am very tempted to quote that the predictions are very hard, especially about the future. And we certainly appreciate and understand that fine point, and especially for complexities such as monsoons. Prediction of extreme events, cyclones, and heavy rainfall have also improved due to continuous efforts by the Ministry of Earth Science and its scientists. Field experiments are critical in understanding the physical processes in the atmosphere and then modeling them to give improved forecast. The recent cloud aerosol interaction and precipitation enhancement experiment has been successfully run at IITM. It was a unique cloud physics and weather modification experiment. The program was initiated in 2009 and used 2 aircraft carrying state-of-the-art scientific instruments for studying cloud properties. The overall goal was to formulate guidelines for rain enhancement over the rain deficient areas. There is an increasing demand by the state governments to carry out viable rain enhancement options. This is so magical. When I talk to people about rain and clouds and monsoon, the first thing they ask is, hey, can we see the clouds? Can we get some more rain up here? And it's very hard to explain them that it's easier to discuss it than to do it very efficiently over large areas, especially during drought periods or in rain shadow regions. Although cloud seeding is being considered in many countries, science-based guidelines are needed to effective planning and ensuring the best use of resources. The program has successfully completed and the results are being evaluated and protocols are being formulated. With this, India will be among the selective countries that have conducted such experiments. A dedicated high-altitude cloud physics lab has been established at Mahabaleshwar. The lab continuously observes clouds and their properties, enabling the study of complex processes over a long period of time. Ministry of Earth Sciences recently acquired 100 acres of land near Bhopal in central India, where a research test bed is proposed to be established with an aim to understand the processes governing convection and land atmosphere interactions over core monsoon region. This site will be first of its kind facility in India. And indeed, I'm sure that with the international partnerships, that many of these test beds, that much of the knowledge and information and data generated in India would be found useful by our partners, international partners as well. ICCP 2021 will help stimulate the exchange of knowledge between experts from around the world, as well as young researchers, and help in enhancing. Oh, by the way, we are all young researchers, some are younger. So when I read the stuff about young researchers, I'm just reminded, I've never met an old person, certainly not an old scientist. So I think it's fantastic to have a gathering of younger scientists, young scientists, and it would help in enhancing our understanding of cloud processes and how they affect precipitation. So I wish the conference all the very best going forward. Let's make new friends, let's make networks, let's exchange information that would benefit all of us together. Thank you very much.
Thank you, Professor Sharma, for the kind words. And we really hope to achieve what you have planned for us in the next few years. Next, I would like to invite the Director General of IMD, Professor Mohapatra, to say a few words.
Good evening, good morning, good afternoon. Namaskar to all of you. Respected Professor Ashutosh Sharma, Secretary, Minister of Arts Sciences and Department of Science and Technology. Professor Ravi Nanjundiah, Director, Indian Institute of Tropical Meteorology. Dr. Thara Prabhakaran, Dr. Gopal, Dr. Mani, Professor Greg, and Professor Andrea Flossmann, Professor Darrell, all distinguished delegates, ladies and gentlemen. At the outset, I congratulate Indian Institute of Tropical Meteorology for taking this opportunity to organize 18th ICCP in India, and hence giving an opportunity to all the young and old meteorologist practitioner students in the region to participate in this event. I also express my gratitude to international committees for choosing this venue and enhancing the opportunity for interactions, networking, and joint activities on this important area of research, this cloud and precipitations. So when you consider South Asia, India, you will find that monsoon is the life for the people. As Professor Sharma has told, there has been a lot of initiatives by the Ministry of Arts Sciences with respect to the research and development, operationalization, and the forecast and warning services with respect to clouds and precipitations. The monsoonal clouds also have different characteristics leading to different types of severe weather during different phases of monsoon, especially during onset phase, active and weak phase, and also the withdrawal phase of monsoon. And accordingly, different parts of the country and in different parts of the South Asia, there are different types of impacts because of the different types of clouds development and their interaction with the physiography, which varies in the region. It is needless to mention that the Great Himalayas, apart from the various hill ranges like Eastern Ghats, Western Ghats, the Myanmar Hills, Garo-Khasi Jaintia Hills, play a dominant role in modifying the convection and the clouds, and hence the monsoonal precipitations, its distribution, intensity, and the impact on various socioeconomic sectors. So therefore, it is still challenging to find out the characteristics of these clouds and hence the precipitations, and needs the more specific observational campaign and the forecasting demonstration projects. So in this direction, with the able leadership of Ministry of Arts Sciences, the various organizations, including IITM and Sharma and IMD, are working together and trying to improve the observations, modeling, and hence the forecasting, along with the understanding of the physical processes of the clouds and the precipitations. I just want to mention here for the delegates, distinguished delegates from outside, that apart from monsoon, India also experiences different typical characteristics of the clouds and hence precipitation in other seasons. For example, northeastern states experiences floods in the month of April or in the month of May because of the very intense convective clouds leading to heavy downpour, which also not only leads to floods, but also leads to landslides over the region, killing the people. Similarly, during winter season, we experience different types of weather systems like western disturbances, which passes through the western part of the country and northwestern part of the country, and causes different forms of precipitations like hailstorms, snowstorms, apart from the rainfall. So India, being a big country, experiences all forms of precipitations, and also the lightning thereof arising out of the clouds developing over the region. I just want to mention here, lightning is one of the killer in this region, claiming a life of around 2,000 to 3,000 every year. So therefore, the cloud physics and its integration in the numerical modeling is still challenging. And I hope this August conference will help each of us to fine-tune our approaches, to have a network approach to the pending issues, the scientific problems, and hence we can come out with the solutions to serve the country better and serve the nations and people better. I wish this conference a grand success. Thank you.
Thank you, Dr. Mohapatra. Next, I would like to invite Professor G.S. Bhat from IISc Bangalore and the chair of the National Organizing Committee to say a few words.
Ladies and gentlemen, Namaste. On behalf of the National Organizing Committee of ICCP 2020, it is my pleasure and special privilege to welcome all the participants of ICCP 2020 to this inaugural function and to the technical sessions spread over 5 days. Your presence and active participation are very important to us. We were very keen to host you physically. Initial preparations were made, however, very unfortunate that we missed a great opportunity to have world top experts in the area of clouds and precipitation here in Pune. This would have enormously benefited both senior and early career scientists as well as students working in the area of monsoon and clouds in India. Clouds play many crucial roles in Earth's climate system. A tropical country like India is blessed with two important natural resources, namely plenty of solar radiation, that is energy, and abundant freshwater supply from clouds. Economy and social practices are closely tied to monsoon, which to the inhabitants of this country, as previous speakers have said, means rainfall. Hence, understanding and predicting rainfall are crucial both societally and scientifically. However, remain among the hardest tasks in meteorology. I look forward to seeing new progress being made in this direction during and as a follow-up of this conference. I hope that there will be a lot of interactions among the participants and on and off the virtual platform, and all sessions go trouble-free. We look forward to a very successful conference. Thank you.
Thank you, Professor Bhat. And I think everybody in the LOC also echoes your thoughts about having people here physically. It would have been wonderful during the monsoon and the Sahyadris.
Yes.
It's just beautiful. On that note, I would like to invite the president of ICCP, Professor Andrea Flossmann, to say a few words on behalf of the commission itself.
Thank you. Honourable Secretary of the Ministry, Director General of the Meteorological Department, Director of IITM, dear cloud physicists, dear colleagues and friends. I am happy to welcome you finally to our 18th Cloud Physics Conference. You probably know that later this month, the next scientific part of the IPCC assessment report will come out. And it's no surprise, it will confirm that clouds are still the major uncertainty regarding climate projections. So our work is important. As was mentioned also earlier, was planned to hold this conference 1 year ago in the city of Pune, in the beautiful country of India, a country I'm trying to honor in wearing a sari. IITM, in particular, Thara Prabhakaran, who did most of the organizational work, wanted to create an unforgettable conference in the spirit of our usual series of conferences. The pandemic, unfortunately, forced us to postpone the conference 1 year and finally to hold it completely online. I know that IITM feels cheated out of their conference, but we tried to put together instead a remarkable online event. I would like to thank Thara and her team at IITM for the wonderful work they are doing and which will guide us through this week. We will start each day with a half-hour plenary talk at 12 UTC to accommodate our different time zones. We are a global community after all. This is followed by 2 parallel sessions with 5-minute scientific talks. Just a fair warning, you will be cut brutally when running over the allocated time slot. We refrained from doing complete 15-minute talks as we would do normally in an on-person conference, as we consider them too tiring for the online version and also with respect to our different time zones. However, full-length version of the talks should also be available to enjoy at your convenience. The 2-hour oral sessions will be followed by 2 parallel 1-hour poster sessions. After this, we have another hour of interactive discussion events on different topics each day, helping to shape cloud physics for the future. For details on the different topics and sessions, please study the conference program. For this platform, we use 3 different platforms. The main login is done from the AirMeet platform, which serves as the entry point and hosts the plenary and session talks. iPoster hosts the poster platform, and the social networking, meeting, and events will be done on GatherTown. And all platforms are accessible also via the submission portal of IITM platform. We hope that all works smoothly and that you find enough time to present your science as well as discuss with colleagues. We invite you to explore the site at your leisure and familiarize yourself with the different platforms. A help desk on AirMeet will assist with any remaining problems. Now, the only thing left for me is to wish us all a fruitful and interesting conference and see you again later during today's event discussion at 16 UTC, where we will give you the news on the ICCP Commission composition, the new president, officers, members, some more thanking, and we will present also the next venue. Thank you.
Thank you, Professor Flossmann. I agree. Fingers crossed that everything works well and the internet gods are kind to us. Now I would like to invite back Professor Nanjundiah to announce a new exciting lecture series that's going to happen as a part of this conference. I'll just share my screen quickly. So Professor Nanjundiah, you can take over.
Thanks, Anu. Ladies and gentlemen, I'm very happy to announce this series on cloud precipitation and dynamics, physics and dynamics, where we have a real galaxy of confirmed speakers. Which, as you can see the names here, it's like the top people in this area who are going to give lectures. Of course, unfortunately, it will still be a virtual lecture series, and it will be twice a week. And as you can see the names from all parts of the world, you can see them, some from India, some from US, some from Germany, etc. And I look forward to listening to these experts and understand what's more about these topics. As you can see, there's a wide range of topics that we are going to discuss in this series, which starts with an introduction to cloud physics, goes on to give microphysics, etc. And we also do explicit modeling of clouds, largely simulations, and of course, their application in cloud physics. Further, we go down the scale to direct numerical simulation and apply it to cloud physics. Of course, being in India, clouds and monsoons and their structure are very important. And then when we talk of it, we also are going to look at the cloud microphysics and how we parameterize them, and how we kind of do clouds in a laboratory, and what are the outstanding problems that we need to address. And of course, there are a whole plethora of topics, which includes principles of thunderstorm and lightning, physics of clouds, etc., etc. So I invite all of you to attend these virtual lecture series and make best full use of this opportunity. Thank you.
Thank you, Professor Nanjundiah. To end the inauguration session, I would like to invite back Dr. Thara Prabhakaran to give the vote of thanks.
Thank you, Anup. Just first of all, let me thank the first and the foremost our on behalf of the ICCP LOC at IITM and the ICCP Commission. I thank our distinguished Professor Ashutosh Sharma, Honourable Secretary, Department of Science and Technology, Ministry of Earth Sciences, for accepting our request, even though at a short period of time, and inaugurating this conference. Thank you so much, sir. We next thank Dr. M. Mohapatra, Director General, India Meteorological Department, for his wishes for this conference. I extend my gratitude to Professor Ravi Nanjundiah, Director IITM, for his exceptional guidance and support for this conference. A big thank you to Professor Bhat, National Organizing Committee Chair, ICCP 2021, for giving us all the support and blessings that have helped us to come this far with the ICCP. I want to thank three people. Next, Professor Andrea Flossmann, President of ICCP Commission, Professor Greg McWaffer, Professor Dr. Darrell Baumgartner. They were the fundamental pillars for this conference, and they played a pivotal role in making it this conference really happen, even in this difficult situation. I really want to thank you deep from my heart. I have also, they have provided guidance for every step. Thank you for every moment, every email, and every discussion that you patiently facilitated. I want to thank Dr. M. Rajivan, former Secretary MOES, for his invaluable guidance and support in bringing the ICCP conference to IITM, and also a wholehearted thank you to the program advisors from MOES, Dr. Gopal Iyengar and Dr. Pavinda Maini. And I also want to thank all the members of the LOC and several other scientists, administrative staff at IITM who helped in various ways. Also, my heartfelt thanks goes to one of my colleagues, Mr. Tulsiram Kushwaha, who helped develop the conference website dedicatedly. I finally want to thank Medha Deshpande for getting us started on a beautiful melodic note. And I still finally want to thank Anup for comparing and giving us a wonderful time. Thank you.
And Thara, don't forget to appreciate Professor Flossmann, Andrea, for wearing a great sari.
Yes, indeed, sir.
Thank you very much.
That indeed, sir. We are very thankful to her for that. So whole India, I told her, all India will honor her for. Thank you. Yeah, I think.
Okay, thank you everyone for coming to the inauguration session. We will continue with the first plenary talk, which will be given by Professor Ravi Nanjundiah, and he's going to be talking about the Indian studies on clouds at IITM, highlighting most of the work that has been taking place within our institute over here. The speech will be given on Zoom itself, but it is being streamed live on AirMeet. Sir, I'll share my slides quickly, and then we can start off.
Thanks, Anup.
Please
Good
go
evening,
ahead.
ladies and gentlemen. I welcome you again to this international conference on clouds and precipitation. And to begin with, here is the panoramic view of our institute. It's in a beautiful location with gentle hills at the back, or actually on all sides of institute, or all sides of Pune. So I wish you were here to come and participate and enjoy, especially in the monsoons, where it's a fantastic thing to kind of look at monsoons, especially in Pune. Next slide, please. Just to give you a brief history of IITM and its vision, it was started on 17th November 1962, which we also call as the Foundation Day. And Professor Pisharati was the first director of IITM, which was called as ITM at that time. And he was the one who was instrumental in starting research on monsoon clouds. If you look at the vision of my institute, that it wants to be a global center of excellence. I would say it's already a global center of excellence through basic research on all aspects of tropical ocean atmosphere system, which is required to improve weather and climate forecasts. We also do research and development, which is required to improve skills of both weather and climate forecasts. And I would say that we are very close to having the best forecasting system in the world, at least for the monsoon regions. We also do quite a bit of work on regional climate change, especially for the South Asian region, so that we can provide reliable projection of monsoons and of climate change. Next slide, please. Here is an overview of the different programs at the Indian Institute of Tropical Meteorology. On the left is essentially, you could say, observations, which includes KIPEX, led very ably by Dr. Thara. Then we have WIFEX, which is about fog and air quality modeling, and thunderstorm dynamics. We have a network of lightning sensors to understand thunderstorms. Then we have 3 test beds: the orographic precipitation test bed at Mohapatra, an urban test bed in Mumbai to study processes in an extremely urban setting, and also to kind of do measurements and also use it for forecasts, or rather nowcasts. Then we have a core monsoon test bed, which is in near Bhopal, which was already mentioned by our secretary and also by others, that this is one of the biggest facilities that's going to come up in not only in India, but I think the most of the tropics. Well, if we look at other areas, we also do a lot of work on climate change and research on climate change. We have our own Earth system model, and we are also doing downscaling, or rather giving information to on regional climate change. We have a very major project called Monsoon Mission, whose aim is to improve forecasts at all scales. And we also have a significant amount of research going on for air quality and weather and climate research. Next slide, please. I'll first talk about KIPEX, which happened in the last 2 years. And it was a major success. Thanks, Dr. Thara. We did 480 hours of observations near Sholapur, which is in the rain shadow region of Maharashtra. We had a ground observational facility, a C-band radar, a aerosol laboratory, and a rain gauge network. We did about 278 cases of randomization seeding with aircraft. And to support it and to help us to kind of pinpoint the clouds, we had numerical simulations of cloud seeding. We also evaluate the seeding impact. Here are some of the details of the experiment. For the lack of time, I'll skip all that. Next slide, please. Now I'm going to talk about the orographic test bed, which is at Mahabaleshwar. We also call it as a high altitude cloud physics laboratory. It's located in Mahabaleshwar, which is, I guess, at a height of about 1.5 kilometers or more. And we have a plethora of instruments to study various aspects of monsoons. And the interesting thing is, just as the monsoon and the clouds of the Arabian Sea come off, there is a steep orography on which Mahabaleshwar is situated. And we have radars of all kinds, which we use to understand clouds and cloud processes. Next slide, please. Here is a set of instruments that we use, a large set of them, which is used for understanding various processes about clouds, including cloud aerosol interaction, etc. Next slide, please. As I said, we have an atmospheric research test bed in central India near Bhopal, and its objective is to provide experimental test bed for the study of important atmospheric processes, especially clouds and convection, land atmosphere interaction, aerosol radiation, and thunderstorms. And so that these could help us to develop and test models in weather and climate, and also by implementing advanced measurements of clouds, radiation, and precipitation in the core monsoon zone. This is right at the heart of the core monsoon zone. That's where it's in Madhya Pradesh, and a large number of the systems which pass over it. So we get invaluable information about what's happening within the core monsoon zone. This would be the first of its kind in the country, and perhaps first of its kind in the tropics, and very few across the world with having this kind of an instrumentation. We have about 100 acres of land, and we already have a C-band radar working there. And this is a kind of a plan of the future where we have different instruments which will be set up at this test bed. Next slide, please. We have the urban test bed, which includes a short-range radar network for mapping Mumbai rain. And it is in collaboration with the India Met Department and also with the state government for helping state management departments, disaster management departments, railway, and for logistics to set up these rain gauges and radars. We have about 140 rain gauges in the Metro Mumbai area. And we also have an application called Mumbai Weather Live, which gives almost present conditions in over Mumbai, over various parts of Mumbai. We propose to have a set of X-band radars, and also with high temporal resolution and spatial, that is about as fine as 3 minutes, and spatial resolution of 50 meters. And these for data set will be used for flood forecast. We kind of run downstream flood forecast models using this information through this radar and rain gauge. It will have rapid updates of rainfall, which is very important for forecasting flood and disaster management. I guess one of my colleagues, Dr. Panditrai, will give a talk on this topic. Next slide, please. Another area which is kind of not appreciated very well is the yearly deaths due to lightning over India. And this is kind of a time series of it. And as you can see, it is continuously increasing over time. And the figure below gives you the state-wise deaths for this 2015 to 2019 period. And you can see that it's highest over Bihar and Jharkhand, which is the eastern part of India, and much less in other parts of the country. And to make this, we have made an effort to reduce these deaths, which is of the order of thousands. It may, I mean, since there are isolated incidents, at a single look, we don't get the numbers, but over an annual period, if you look at it, it's over 2,000 increase. So IITM has made an effort to reduce the yearly deaths due to lightning, and we have set up locational sensors across India over various parts. And most of the lightning we found was between 4:30 to 5 in the evening, and there was cases where more than 100 people died in Bihar and UP on this day. And now sensors are placed on all the states and union territories of India. And we also have an app which gives you information about the lightning and also alerts people on a real-time basis. Next slide, please. And to kind of predict so that we can reduce those casualties, we also have a lightning prediction system in IITM. We have developed it based on models. And we find that thanks to the modeling work that we have done, there is a reduction in the number of deaths, about 37% reduction. And it's only 2 years since we had it, but it looks like it is giving us very good results. Next slide, please. We also have a set of drones which we are using and we propose to use to study lower atmospheric area. And this has been set up. We already have 2 drones. And now we plan to use and profile lower atmosphere for high frequency measurements of meteorological and atmospheric parameters, especially in the boundary areas. And spatial and vertical profiling of in situ measurements of physical and chemical properties will also be undertaken as part of this unmanned facility, which is called LARIS. Yeah. Next slide, please. We have, I mean, fog is one of the major concerns over North India, especially over Delhi. It kind of disrupts all walks of life, especially transport, both railways and airline schedules. They go haywire whenever there is, say, a thick fog. And to understand the causes behind fogs, we have an experiment called as the Winter Fog Field Experiment, WIFEX. And we study characteristics and variability of fogs over Delhi and associated dynamics of the fog and also its thermodynamics. And we also now have a model which does forecasting and also now casting. So it gives a fairly high resolution, 2 kilometer operational fog forecasting system has been set up. And we are in the process of doing this kind of a fog forecast, perhaps at a little coarser resolution over most of North India. We have had 6 phases of WIFEX. And one of the major outputs that this forecast gives is the local visibility, which is very important for most of the country. Next slide, please. Air quality is also a major problem in metros like Delhi. So we have a public dissemination system, and it has both for general public and advanced user. General public, it kind of gives warnings and also tells you about the air quality, and also kind of time for the advanced user. We show the time series of it and how the model has behaved. And also looks for shows various pollutants such as PM10, PM2.5, ozone, NO2, and SO2. And for AQI and its forecast verification, we kind of output a large number of variables. Next slide, please. We are in the process of setting up a decision support system for air quality in Delhi. And the major new information that we are going to get from this decision support system is where the pollutant is coming from, or is it locally generated, and whether it is what is the cause of it, whether it's natural or is it anthropogenic. In and around Delhi, We do have a lot of anthropogenic pollutants, but we also have quite a bit of dust blowing across from Rajasthan and the adjoining areas. So it can have both the natural and anthropogenic components of various pollutants such as PM10 and PM2.5. So, and we also look at whether it's a local or a non-local condition. And we also give forecasts for different emissions in air quality. Next slide, please. During lockdown, my colleagues looked at the air pollution or the pollution status in different parts of the country. And they looked at the pollutants, which are basically 2.5, 10, and NO2. And we found that there was a significant decrease in the pollution concentrations at various cities, including Delhi, Ahmedabad, Mumbai, and Pune. So it will have a strong implications to policy framework and control strategies, because the information that we got, when that is with reduced pollution, there can be a significant improvement in air quality, and we should work towards improving the air quality in our country. So this would be an invaluable information. Next slide, please. Another flagship program of IITM is the Monsoon Mission Program. It is a unique program which is targeted to improve predictions of weather and climate over India, and also to strengthen India's position in making weather and climate forecast capability, which would be at par with other leading centers in the world. And in the last 4 years or 5 years that it has been in operation, it has been, I would say, a very good success. And till now, it has developed and delivered products to India Met Department, which includes a seasonal forecast system for Indian summer monsoon, whose skill is best, or even I would say better than other leading centers as far as the Indian summer monsoon is concerned. We do have an extended range prediction system for predicting active and brief cycles of monsoon, that is periods of when heavy rainfall, relatively heavy rainfall over a large period as compared to break, where it is kind of monsoon is inactive, which is extremely important, especially for farmers, so that they can do their sowing patterns based on that. And other important spin-offs of this is the heat and cold waves, which also forecast with very good accuracy. And also we are able to pick up cyclogenesis well in advance. So the highest short-range ensemble prediction system in the world, we are having a capability which is comparable to the best system in the world, or perhaps I would say the ensemble system is at the highest resolution. And it is helpful in forecasting extreme events at a lead of 3 to 5 days. We also have a lightning prediction system working in this mission, and we, as I already mentioned about it, the lightning and thunderstorms are predicted. And an early warning system over Delhi is also has been developed, and as I told you about the decision support system, etc. And all the forecasts at various scales are useful for applications to agriculture, hydrology, health, and wind and solar energy, and also for forecasting forest fires. So it's a wide range of areas where the products from Monsoon Mission are being used in all these areas, and has been a boon for the country in various walks of life. Next slide, please. So this is some work we are doing, which is, I would say that it's comparable to the rest of the world, or even better than. It's called as weakly coupled data assimilation, WCDA. So the important thing about it is that generally when we do assimilation, we I say that is start the initial conditions or create initial conditions for atmosphere and ocean separately. But when we couple it, then both of them come together, and the information from the ocean goes to a land, atmosphere, and vice versa. So which kind of tends to improve the skill of assimilation. This is in early stages, and it's ours is one of the few centers which have developed such cutting edge technology. Next slide, please. As I mentioned, we using various walks of life, which includes an early health warning system in the extended range, that is about 20 to 40 days. And we have used it to understand or even forecast two diseases such as malaria and acute diarrheal disease, which is very important, especially during the monsoon period. And we found that high minimum temperature and moderate maximum temperature are more conducive for malaria and diarrhea. So we have developed right now only for two cities, that is Pune and Nagpur. And once we have more data from different parts of the world, we will be different parts of the country will be trying to expand it to other cities also. Next slide, please. Another area which we have ventured into is the forecast of solar radiation and wind energy. And here is a comparison of the solar energy power with our model forecast and also of other global centers. And we find that our model is performing better as compared to the other models of the world. And it has an accuracy of about 15% plus minus, and which is as per the Ministry of Renewable Energy regulations. And we are also giving it, of course, gratis to various public sector agencies such as Prof and a number of other private renewable entrepreneurs. We also have looked at the wind forecasts, and it looks like the forecast that we are getting is pretty good. Next slide, please. Another major area for our institute is the Center for Climate Change Research. The major feather in our cap is the development of the Earth system model, the first of its kind in India. And it is contributing to CMIP experiments, and will also the information from that will be used in the soon to be released IPCC AR6. And data from this ESN can be downloaded through the EFGH node at IIT. We're also doing downscaling experiments, which we call as Vortex for South Asia. And we have developed a multi-high resolution ensemble projections of regional climate for South Asia. And it's also used for assessing the impacts of climate change on various sectors such as water resources, crop yield, and health. We're also conducting measurement of greenhouse gases and other related fluxes over different ecosystems. Next slide, please. And one of the major achievements of our center, this is the Center for Climate Change, is the release of a public assessment of climate change over the Indian region. It contains various information about how human-induced global change will affect the Indian subcontinent. It presents a synthesis of historical and projected changes in the global and regional climate over India. And it has been found to be very useful as a reference resource for researchers, practitioners in academia and industry, and also for policymakers. Next slide, please. These are some results in comparison with observations for historical and future runs of the IITM. I mean, I'll skip at this point. All I would like to say is it's comparable to what the rest of the models over the rest of the world are. I mean, the information is as good or even better than what the other models are showing. We also have a very large observational program at CCCR. We study carbon sequestration in the Kaziranga forest of Northeast India, and also for mangrove forests in various other locations. We're also in the process of setting up a climate reference station network over various centers, over various places in India. Much work has also been done over southern Indian Ocean, and cruise-based observations for various climatically sensitive halogen and sulfur gases have also been conducted. And we are in the process of improving it's a kind of a data sparse ocean. So this data would be very valuable to kind of create a comprehensive data set. And we have been doing greenhouse gas measurements from 2009 to present. To do all this, the simulations, and also to store huge amounts of data, we have HPC, the high performance computer. We have 2 of them which are operational at IITM, Aditya and Pratyush. And also IITM acts as a nodal center for establishing HPC resources, both at IITM and NCMRW, that's the National Center for Medium Range Forecasting. We have recently set up an atmospheric research data center with all the data collected by MOES scientists, and is now established using the live access server. And as of now, more than 150 terabytes of data is available online for the research. In future, we have to have an upgradation of the computer to about 150 petaflops, which will be done in phases. Initially, we will be doing about 20 petaflops in the next 2 years, and also kind of gradually increase it to about 100 to 110 petaflops in the 5 to 6 years. And currently, the computer we have is the fastest of its kind. And various applications have been worked on it, which includes seasonal and extended range prediction, air pollution forecast, and also direct numerical simulation, tsunami early warning system, and also, of course, projections. Next slide, please. We also have a very good training program at IITM, which organizes courses for our students and also for scientists at all levels focusing on the research objectives of MOEs. We also have a national fellowship program, not just for our own institute, but for the entire Ministry of Earth Sciences, where we select students, very bright young students, to work in various institutes of MOEs. And we also have very targeted training programs, which is about 5 to 7 days in the form of some of schools and a workshop. We approximately do them about 8 per year. And our idea is to strengthen research and education support for science and climate and climate change, and to establish linkages with other education, research, and operating organizations in the country. Next slide, please. So to look at future directions or where we plan to go, we propose to improve forecasts at all scales with improved models at higher resolution. The input data we get from the observations such as Skypex and the various test beds, they'll be invaluable to kind of look at clouds, which is the weakest link in all models. We propose also to do climate change studies at higher resolution and also do global downscaling instead of regional ones. That is, we kind of downscale for the entire globe rather than only for one region. That's what we are doing. And we also propose to conduct more intensive observations on monsoon-related processes at the various test beds. And we are committed to improving the air quality forecasts and its studies. It looks interesting, and we look forward to more exciting times ahead. Thank you.
Thank you, sir. And now we don't have much time left for a discussion. So I would request everyone to move to the AirMeet platform. Thank you. Anup, please.
Okay, thank you, Thara, and thank you everyone for coming for this session, the inauguration session, and listening to the wonderful talks that were given today. We hope that you have a nice meeting. It's going to be 5 days of intense talks and intense activities. So keep your energies high, and I look forward to interacting with you over the next few days. Again, thank you so much for making time for coming for this, and we'll see you in the future.
Yeah, I think we can